In this video, we're going to do a few examples of what I call work problems. And these work problems are problems that involve solving rational equations. So this problem says if the cold water faucet is left on, the sink will fill in 15 minutes. If the hot water faucet is left on, the sink will fill in 17 minutes. How long would it take to fill the sink if both faucets were left on? And the problem that I just read to you is a common work type problem. We'll be able to identify these because there's always some work being done by one or more persons or one or more things. Here, the cold water faucet is doing some work, it's filling the sink, and the hot water faucet is filling the sink as well. In other examples, it may be a painter painting a house that can do it in a certain amount of time and another person that can do it in a different amount of time, and if they work together, how long will it take them to get the job done together? Another example might be Mr. Holly grading papers. If Mr. Holly can grade all the papers in a certain amount of time and his teaching assistant can grade the papers in a different amount of time, how long will it take them if they work together to grade the papers? So there's a common theme of work being done or a task being accomplished with all of these work type problems. And we'll approach them all basically the same way. We'll begin by identifying the amount of work done by each person or thing in the problem. So we can see here that the cold water faucet can fill the sink in 15 minutes. So let's write an expression that signifies the amount of work being done by the cold water faucet. We know that it can complete this job of filling the sink in 15 minutes. So we can express the work done by the cold water faucet like this. One job every 15 minutes. We can express it as a ratio. We'll define the amount of work done by the hot water faucet the same way. The hot water faucet can fill the sink by itself in 17 minutes. So the work done by the hot water faucet can be expressed by the ratio one job every 17 minutes. But we want to know how long it would take to fill that same sink if we have the hot water faucet running and the cold water faucet running at the same time. Well, if they're both working at the same time, it would make sense that we would add the work done by the cold water faucet to the work done by the hot water faucet. So to calculate the work done by both of the faucets, we add 1/15 and 1/17 because one job every 15 minutes plus one job every 17 minutes equals one job every how many minutes? And that's the question that we need to answer. How many minutes will it take if the faucets are working together to fill the sink? So here's our equation. One job every 15 minutes plus one job every 17 minutes equals one job every X minutes. And we need to solve this equation for X. Let's start by adding 1/15 plus 1/17. The common denominator is 255. 1/15 is equal to 17 over 255, and 1/17 is equal to 15 over 255, and that's equal to 1 over x. Adding the two fractions on the left gives us 32 over 255 equals 1 over x. This is a proportion, so we can solve by cross multiplying. Cross multiplying gives us 32x equals 255. And dividing both sides by 32 to solve for x gives us x equals 255 over 32. Now remember here, x represents the number of minutes it would take both faucets working together to fill the sink. 255 over 32 is the exact amount of time. And we're told here that we can write our answer as an integer, a simplified fraction, or a mixed number. So let's write this as a mixed number because a mixed number will give us a better idea of exactly how many minutes 255 over 32 minutes is. That gives us x equals 7 and 31 30-seconds of a minute. So the time that it would take to fill the sink with both faucets running is almost 8 minutes. Not quite 8 minutes, but very, very close to 8 minutes. 7 minutes and 31 30-seconds of a minute. This example says a pipe can fill a reservoir in 14 hours. Let's stop right there. How can we represent the amount of work that that pipe does? That pipe can complete one job in 14 hours. The next sentence says a drainage pipe can drain the reservoir in 25 hours. Now keep in mind, the first pipe was filling the reservoir. This pipe is a drainage pipe and it's draining the reservoir. And the question is, how long would it take to fill the reservoir if the drainage pipe were left open by mistake? How much work is the drainage pipe doing? Well, the drain pipe is not working with the fill pipe, it's working against it. If the fill pipe is completing the job of filling the reservoir in 14 hours, but the drain pipe is draining the reservoir in 25 hours, we would have to represent the work done by the drain pipe as a negative value because it's working against the fill pipe, not with it. Since the drain pipe is taking away from the work done by the fill pipe, we would say the amount of work done by the drain pipe is minus one job every 25 hours. So how long would it take to fill the reservoir if one pipe is filling it in 14 hours, but another is draining it every 25? That amount of work can be expressed as 1/14 minus 1/25. And that would be equal to 1 over x, which signifies one job completed every x minutes. So let's get a common denominator and combine the two fractions on the left. The common denominator between 14 and 25 is 350. 1/14 is equal to 25 350ths, and 1/25 is equal to 14 350ths. And that's still equal to 1 over x. 25 minus 14 is 11, so the left side of our equation is 11 over 350 is equal to 1 over x. Solve by cross multiplying. That gives us 11x equals 350. Now divide both sides by 11. That gives us x equals 350 over 11. And because x represents a time in hours, that would be 350 over 11 hours. But again, let's change this into a mixed number to get a better idea of exactly how many hours this is. As a mixed number, 350 over 11 is 31 and 9/11. So leaving the drain pipe open while we're filling the reservoir, it would take 31 and 9/11 hours to do this. So really, really close again to 32 hours.